If you were to ask a mathematician what are the most important numbers in mathematics, you could get this list: 0, 1, pi, e, and I. Now we're going to do videos on all these numbers right here, but I want to start with pi because we have Pi Day coming up 3/14/2015, and at 9:26:53 in the morning and in the evening, these numbers will give us a very close approximation to the number pi: 3.141592653. So on Pi Day we celebrate pi. Look, there's no other way to write this. We can't write pi as a fraction, and there's no decimal number that's equal to pi. Pi is an irrational number, and this is the symbol that we use to represent it. Now, where does pi come from? Well, people just discovered it naturally. If you look at a circle and you measure the distance around the outside of the circle, that's called the circumference. If you go across the middle of the circle from one end to the other through the center of the circle, that's the diameter. And people just noticed as they worked with circles that no matter how small or how large the circle was, that ratio of C to D always comes out to be the same number, or it looks like it always comes out to be the same number. So you can actually get an approximation to it just by measuring. Take a little string, make it into a circle. You know the length of the string, measure the distance across the circle, divide those two numbers, you get an approximation to pi. You could actually put a long rope into the ground at one point, stretch it out and walk around in a circle, just count your steps, then walk across the circle, divide those two numbers, you'll get an approximation to pi. But what is the number pi? What is it mathematically? How can we get close to it? Well, the first person to do that did it geometrically. It was Archimedes in the year 250 BC, and this is what he did. He took this red circle and he put a hexagon on the inside and another hexagon on the outside touching the circle in these places, and then he found the distance around the inside hexagon, the distance around the outside hexagon, and he said, well, look, the circumference must be between those two numbers. He knows the circumference then. He already has the diameter across the circle, so if he divides that circumference that he's getting by that diameter, then he'll have an approximation to pi. So then he reasons that he can get as close as he wants to the actual number by just increasing the number of sides in the polygons that he uses. So that method of finding pi, or getting close to pi, was geometric, and that lasted till around 1600, when the Scottish mathematician James Gregory found a resolution to Zeno's paradox by being able to add an infinite number of numbers. So he worked with infinite series, that's what we call this right here, and in doing that he found that pi was equal to 4 times this series: 1 minus 1/3 plus 1/5 minus 1/7, so on and so forth. So as you start adding numbers down this sequence right here and adding them up, add the first 2, the first 3, the first 4, multiplying by 4, you get closer and closer to the number pi. So the number pi is actually what you get when you go all the way out to infinity with this. One of the most interesting ways to find pi, I think, is with probability theory by this French mathematician Buffon, who actually is the forerunner of Charles Darwin as he studies evolution. But he does a lot with mathematics and probability, and he finds this. If you take two parallel lines, let's say 1 inch apart or 1 foot apart or whatever, 1 unit apart, and draw them on a flat piece of paper, then you take needles that are the same length that the two lines are apart, and you just drop the needles onto the paper at random. It turns out that pi is equal to 2 times the number of times the needle will hit one of the two parallel lines by the total number of drops. So it's a probability associated with the number pi, and allows you to actually get approximations to the number pi by just dropping these needles onto the piece of paper and seeing how many times they cross those parallel lines. So 3 different ways to look at pi: geometrically, algebraically, and with probability theory right here. I want to remind you that none of these numbers actually exist as objects. These are just concepts, and this is, for instance, not the number 1, but simply some blue ink on a whiteboard that is a symbol that allows us to communicate about this concept, the number 1. The number 1 doesn't exist as an object. No one's ever seen it. No one ever will see it. So we use these symbols right here to communicate back and forth about the number 1, which is a concept that we all understand. So when we look at all this mathematics, it doesn't really exist as objects. It's just a way to communicate, and it allows us to bond with each other in this communication about mathematics, and also allows us to kind of travel back in time to connect with people like Archimedes, Gregory, and Buffon. We might not know exactly what's going on in their society at that time, or even if we did, we might not understand it, or some of their traditions or things like that. But when it comes to mathematics, we know exactly what they were thinking. It's this. So we can connect with them mathematically by what they've written about mathematics, because once we study this and understand it, we know exactly what they were thinking. So we celebrate Pi Day. What are we celebrating? The number pi? Well, we're celebrating more than that. We're celebrating the joy of being human and having this unique ability to do this mathematics that connects us with each other and with people like Archimedes, Gregory, and Buffon.